Okay, so for section 2.2, the use of steel as a structural material. So we look into some definitions of your uh, uh, steel. So as defined in this section, structural steel is the steel elements of the structural steel frame essential to support the design loads. Okay, so such elements are generally enumerated in the section 2.1 of the AISC Code of Practice for steel buildings and bridges. And also this is the referral code of the NSCP. So the AISC is the actually the referral code of the NSCP. Okay, such elements are usually code form. Okay, steel structural members. It can also be a hot rolled. No, so there are a lot of ways on how to manufacture steel. I will give you a video to look into later on the manufacturing process of steel. And these profiles contain round corners and slender flat elements for the cold form. And the provisions of the American Iron and Steel Institute specification are hereby recommended in this. Okay. So we have also three basic types of structural steel. We have the rigid frame, the simple frame, and the semi-rigid frame. So these classifications are just based on how the members are connected in terms of its rigidity requirement. Okay? So if you have here a frame, so sample of frames are building frames. You call this a bay frame. So how many bays do you have? You have two bays and two story. Okay. So the type of rigidity on the connections will define your steel structural steel type. Okay. So if this is rigid, okay. So if this is rigid, normally they are those which are welded, fully welded. Then your type will fall on the rigid frame. Okay. So for simple frames, normally these are referring to simple beams and trusses. Okay, so these are actually used only for gravity loading, and the ends of the beams are only connected to resist shear and shear forces and maybe a slight of moment, no? Pero normally purely shear forces lang tayo dito. Okay, so while a rigid frame is applicable to a building frame or a bay frame, your simple frame is applicable to simple beams and simple trusses. So for type 3, we have the semi-rigid framing, which is in between the two. No? So let's say a semi-rigid framing is such that your bay frame constitute some connections wherein the connections are not rigid, no? So maybe these are just made of uh, bolts or bolted, okay, partially welded, or it can be bolted or welded partially, while these are rigid frames are welded and bolted fully, okay. So when you say fully, the type of connection is really very so well designed as not to allow any rotation. Okay, so rigidity has something to do with the uh, okay, almost zero relative rotation. Okay, when you say rigid, there this will not rotate uh, significantly in terms of its relative position. Okay, so again, the rigid frame is fully welded and bolted. The simple frame are those used on simple beams and simple trusses wherein the connection is only made on the shear and maybe partial moment. And then a semi-rigid frame is such that your connections are partially bolted and welded. Okay? So there's a note here that for trusses and secondary open web structural members, the type 2 framing is unconditionally permitted. Okay, so for trusses and simple beams, this type is unconditionally permitted. So that's the first slide. Any question on the types of structural steel frames? Okay, so okay, no questions? No questions?
Sir.
Okay, so sagot naman kayo ha. Naman kayong nakaupo lang diyan o ano, ano. Baka okay, so let's proceed now with the discussion. So on page 2, the second page, we are going to discuss the materials conforming to one of the following specification. Uh, we have the structural steel plates and shapes, the seamless steel pipe, and the cold form tubing and round Cs. Okay, so this we will be dealing with that shape, those shapes later. Okay, for shapes, normally when you say steel shapes, a plate is flat, okay, a flat steel with a width less than, or sorry, greater than 8 inches, okay? So this is a plate. When it's smaller than 8 inches, you call it a bar, okay? Flat bar. So when this is less than 8 inches, you call it a flat bar, less than or equal. Okay. So for the shapes, we have the American rolled shapes. No? So these are now the rolled shapes. Normally these are hot rolled. Okay. They are manufactured by means of heating uh, your steel material up to its melting. Okay, melting temperature so that you can form it into shapes. Okay, so normally A36, this is the most common grade, you call this the grade of the material. Okay, so we have the pipes which are seamless, there are no joints, and these are the grade, no, normally A53 grade B. And for the cold formed tubes and round and C shapes, okay, so tube, we have the tube, the round, and the C, okay. So these are now cold form, meaning to say you don't apply heat to form it. So these are normally thin, no? Because it's very hard to form it when it is cold. So these are only thin plates. Okay, so for letter B, certified meal test reports made by the fabricator or testing laboratory in accordance with the ASTM A6 and ASTM 568 as applicable. So these are just for certification purposes, that your shapes and types are passing the requirement of ASTM A6 and ASTM 568. Okay, so we have also some unidentified steel. They are those which are free from surface imperfection, and they are permitted for parts of minor importance, provided that its physical properties may be properly evaluated by the engineer through test or visual inspection. So normally these are those which you cannot identify from scrap. Okay, so you can reuse them for as long as you can justify that they are physically uh, what they are physically qualified, or they are physically um, fitted to be used as per evaluation of an engineer. Okay, through test or maybe through visual inspection. Okay, for bolts, washers, and nuts, these are the most common. We have the machine bolts A307. So yung nabibili nyo sa mga hardware, okay? Machine bolts. They are made of carbon steel bolts and studs. High strength, yung A325. So normally sa mga special stores yan. And these are used for fully bolted rigid connection. And anchor bolts, which are normally threaded rods made of A36 steel. Okay, so pwede ka rin gumawa ng sarili mong bolt using A36 shapes. Okay, so they are just fabricated on a lat machine. Okay, totorno lang yan, tapos yun na siya. Okay, for welding electrodes and fluxes, we go now to welding. We have the AWS, or the American Welding Society, as your basis for standard. And the specifications for covered carbon steel arc welded electrodes referring to AWS 5.1. So specification for low alloy steel covered arc welding electrodes as specified on AWS 5.5. And studs and shear connectors which shall conform to the requirements of the Structural Welding Code, still AWSD 1.1. So these are the references that you need to look into whenever you are using welded connections. Okay, so just like a referral code of welding specifications. Okay, so for letter F of this sheet, we have the manufacturer certification, which shall constitute sufficient evidence of conformity with the code. So normally, hindi tayo pwedeng kumuha sa isang factory na hindi siya certified, no? So there must be conformance with the code. So baka ang yung factory na yun hindi siya standard ang pag-manufacture niya, nagkakaproblema tayo sa construction. Okay? So let's talk now on some of the comparison of tensile properties of common structural steel. We have okay, most important properties, the yield point and the tensile. Okay, so if I have here a stress strain curve, so you have there a yield, and then okay, you call this now your Fy, your yield, and your tensile is somewhere there. Okay, Fb. Okay, so this is now your tensile, your yield. This is the elastic proportional limit. Okay, you have the elastic limit there, and you have a second yield here, and then you have here a plastic stage, and then you have your strain hardening. Okay, so we have here the proportional limit. Somewhere here is the proportional limit, somewhere there is the yield point. Okay, so that's the yield point. The first time it yields, then you have here a proportional limit. Okay, you have the plastic stage. Okay, you call this the strain hardening. Okay, of course, this is the elastic stage, wherein the elastic modulus is defined in terms of okay your ratio of stress all over strain is equal to elasticity. Okay, that's one. Okay, so these are the two important property. These are just less important in terms of the tensile ratio, yield to tensile ratio. And this is the elongation in terms of percentages of 8-inch minimum. Okay, so when you say elongation in 8-inch, the percentage is based on the 8-inch sample of this specimen. Okay, for A36 steel, we have 36 KSI, then 58 to 80. Okay, normally we use the minimum. For A572, we have 50 and 65. Also for A992. Okay. So here, you notice that they are just the same, but this is more of a low alloy, and this is for a high alloy steel. Okay, basically what is steel? Uh, Steel is made up of carbon and iron. Okay. So it is made up of carbon and iron, and of course some other elements like sulfur, phosphorus, okay, which are also inherent in carbon. And then when you make use of some metallic substances, you add it with basically your steel, you form an alloy of steel. Okay, so it can be a low alloy, steel alloy, and a high alloy. Okay, so these metal are called the alloys or alloyants. Okay, so if you add metal, what metal? Those are which are manganese. Okay, normally these are the manganese, the chromium or chrome. Okay, ano pa? Mga nickel. Okay, zinc. So all of this metal contributes to your steel increasing your strength in terms of additional metals. Okay, but of course it is very expensive to add these metals, so you only make a very small percentage of addition. No? So normally your steel gets its strength from carbon uh, elements, but you cannot make a very big percentage of carbon, since carbon can actually make your steel brittle. Okay, so it's not good to add a lot of carbon. Okay, for the steel shapes, these are the rolled types that I told you a while ago. Standard rolled shapes. Okay, so these are the rolled sections or shapes. And you'll notice that we have the wide flange, the American standard, S. Okay, so the difference between the two is the sloping side, okay, sloping inside face. And of course, this is wider flanges, okay, so this is wider. Okay, for angles, we have the equal leg and equal leg. And for channels, we have the American Standard channel. Sloping inside face also. So with this one here, okay, so there's a sloping inside the face. Okay, for structural T, normally these are obtained from cut WF shapes. Okay? So pag pinutol ko dito yan, magiging T. Okay? So these are just samples of your roll shapes. We have also what you call the steel pipe, as I was discussing a while ago, and tubes. No? So these are all hollow structural sections, HSS. These are the plate, the flat bar, round bar, square bar. Okay? These are the cold form. Okay, so these are the cold form. These are very thin, no? Thin sheets or thin plates. We also have the built up shapes. Okay, you call this the built up shapes because they are built with some combination of your shapes. Okay, we have the W shape with cover plates. We have the plate girders. We have the double angle, the double channel, etc. Okay, for the shape and preferred steel, so you just look into the table. These are just recommendatory shapes and the steel material by the AISC. Okay, so for angles, we normally use A36 plates and this. So ito yung pinakasikat, no? Available in your hardware store. Okay? For HP, medyo kailangan high alloy ito, no? A572. And for W shapes, normally may A36 din ito, no? Mahal kasi yung A992. And for pipes, we have the grade B. You have this only as your choice, A53. And HSS, you have only a grade B, also A500. Or can be round, or it can be C or rectangular. Okay? So pag B, round siya, yung grade C, rectangular shape. So ibig sabihin mas matibay yung round sa rectangular. Okay, so if pipes, okay, I have a pipe and then rectangular there. So this is grade B and this is grade C. Okay, but they are both A 500. Okay, also you have an A53 pipe, grade B as the only choice. So when you get your actual yield stress, which are not included here in this table, you just refer to your book on Salmon and Johnson to get the actual FY and FU. But today you don't need that because we will not be using any of those in our computation yet. Okay, but as you proceed with steel design, you will be using those. Okay, so and that's all for the discussion today on structural steel as a construction material. So, any questions?
No, sir.
No, sir.
No.
None, sir.
Okay, so that's just a simple okay,